Hello everyone. In this module, we are going to discuss about ray diagrams for convex lens and concave lens when the object is taken at various positions. And also we'll solve one problem from your NCERT that is based on the lens formula, and your lens formula is, as we are going to discuss on the next pages, that is your 1 by V minus 1 by U is equals to 1 by F, or 1 by B, that is your image distance, minus 1 by U, that is your object distance, and this equals to 1 by F, that is your focal length. So this page is showing you the various ray diagrams for convex lens when the object is taken at several positions. Okay, so the first one we'll discuss, that is in your A. The lens, as you can see, mn is representing the lens, and the incident light rays are coming parallel to each other, and this is the position of the object when the object is taken at infinite distance. Infinite distance means it is not in the curvature of the lens, it is somewhere beyond this. Okay, so when the parallel rays are coming from an infinite distance from the infinite object, then all of them will pass through the lens. And why they are passing through the lens? Because this is the process of refraction. In refraction, the light rays will cross the lens and they will bend their path. But in reflection, what happens? They will strike and they will go back to the same medium. So here they cross the lens to enter a different medium. So here you can see the light rays, all of them are coming parallel, and if a parallel light ray is coming, it is destined to go through the focus. So all the refracted rays are passing through the focus. So this is the focus, as you can see. This is represented as F2. This is F1. This is F2. Okay. So image you are going to get at the position of F2. Okay, and the double of focal length, that is known as 2F1, or you can write that C1 also, or on the right hand side it will be C2 or 2F2. Okay, so next coming to the second one, in which object we are gradually the object we are bringing nearer and nearer to the lens. So here you can see the object is represented by AB, and this object is just beyond the 2F1. So when the object is present just beyond the 2F1, the parallel light ray which is coming, that is just trying to go through the focus, so the refracted ray is going through the focus. And another light ray which is passing through the center, passing through the O center, that will not change the direction of the path of the light. So it will be refracted in the same direction, and both the refracted light rays are meeting at this point, intersecting at this point, and the point is your A dash. And from A dash, if you will draw a perpendicular line to the principal axis, the image you will be getting, and where you will be getting the image will be produced between F2 and 2F2. So within this area you will be getting the image, and the image here is A dash B dash. So in the next one, the object has come little more nearer to the lens. So here it was beyond 2F1, and here the object is present just at 2F1, and the object is your AB, same as like the previous two. Here also one light ray is coming parallel, and it is passing through the focus. Another one is passing through the center, and it will passing after getting refracted also in the same direction. So here you are getting the image. Where are we supposed to get the image? When the two refracted rays are meeting. Okay, so the two refracted rays are meeting at this point A dash. From A dash, if you draw a perpendicular to the principal axis, you are going to get the image. So the image here is A dash B dash, that is produced exactly at 2f2. So when the object is taken at 2f1, the image you are going to get at 2f2. Okay, and so in the next one, the object has come little more nearer to the lens, that is now it is present between 2f1 and f1. Okay, between 2f1 and f1, one light ray that just like the previous ones, one light ray is passing parallelly, and after getting diffracted it is passing through the focus, another one is passing through the center, and both of them are meeting at a point. That point is a dash. If you will draw a perpendicular line from a dash to the principal axis, it will be intersecting to the principal axis just beyond 2f2. So if you are taking the object between 2f1 and f1, you are going to get the image beyond 2f2. If you are taking the object beyond 2f1, then you will be getting the image between f2 and 2f2. Just the B and D are opposite of each other. Okay, so next we'll see where the image is. Now the image will come little more nearer. So previously in the D figure it was present between 2f1 and f1. Now it will be present just right at f1. Okay, so the parallel light ray and another one passing through the center, and both of them are meeting in at the infinite position. So it is not shown in this figure. They all are meeting at the infinite position, and at the infinity you are going to get the image. It is also just opposite to the figure A, where the object is taken at infinity and image you are getting at f, and here object you have taken at f focus and image you are getting at infinity. So A and E are just opposite of each other. Okay, so the last one, where which one is very different from all these five. So in the last one you can see the object is taken, it has come very much closer to the lens. Object is taken, here is the object, AB is the object which was placed between F1 and the O. So here also one light ray is coming parallel, another one is passing through the center. The parallelly coming incident ray will get refracted and it will be passing through the focus. And when they are extended beyond this, they are supposed to meet at this point. The imaginary lines are meeting at this point. So here you will be getting a virtual image that you cannot get on the screen. Okay, so you are going to get a virtual image which you have not got in any of the previous 5 figures. So in this one, along with the virtual figure, also it will be erect figure. So the image is going to be erect and virtual. Here you can see the image is erect. Okay, so this A dash and B dash is the image. So if you extend this refracted rays back, okay, as an imaginary line, they will be meeting and you will be getting the image beyond 2f1. Okay, image beyond 2f1 you will be getting, and the image is also virtual and erect. So to remember all this, kind of object distance, image distance, kind of image, and the size of image, that is all present in this table. So from this table you have to remember every kind of position of the object and the image, kind of the nature of the image also, so that you will be able to solve the problems. It will be very easy for the problems to solve when you remember all this 4 columns. Okay, so when the object is at infinity, you are getting the position at focus. It is just opposite to the 5th one. When the object is f1, you are getting the image at infinity. Okay, and this one is very easy to remember. You are taking the object at 2f and also you are getting the image at 2f. Okay, and when the object is beyond 2f1, you are getting the image between f and 2f, and this one is just opposite to this one. When the object you are taking between focus and optical center, you are getting the image on the same side of the lens and beyond 2f. Okay, so sorry, these two are opposite to each other, second and fourth one. Okay, so this is how you can remember the table. And the relative size of the image is also given. So as we are going nearer and nearer to the, as the object is going nearer and nearer to the lens, the size of the image is getting increased. When the object is at infinity, very far from the optical center, the image was very highly diminished, very small point sized. But as the object distance is decreasing, okay, object distance is decreasing and it is coming nearer to the lens, the size of the image is increasing. Okay, and the nature is always, it will be real and inverted except at one position, that is in the last one, that is your the nature of the image is a virtual and erect. Okay, so next we'll be see how the kind of the image is formed in the concave lens. Okay, concave lens, how which kind of image is uh, produced. Okay, so in concave lens also there are only two positions to be discussed here. Okay, so one is when the object is present at infinity, another one is when this one is your infinity. Okay, the parallel light rays are coming, and this one is at the in anywhere, okay, between anywhere between your infinity and optical center. Between infinity and optical center, if you are placing the object anywhere, then you will be getting the image between focus and optical center. At this area you will be getting the image, and in this one, when the light rays are coming parallelly, obviously you will be getting the image at the focus. Okay, so they will be refracted and they are diverging light rays, because concave lens is kind of a diverging lens, so it is diverging the light rays, and when you are extending them backwards, you will be getting the image at the f1. Okay, and in the second figure you can see we are taking the object anywhere between the between to f1 and f1. So one light ray is going parallel and it will be refracted, and if you will extend it beyond, then it will be passing through the center, sorry, focus. Okay, and if it is passing through the center, it will be, it will not be changing its direction. So here you are getting the intersection. Okay, so from the intersection, same draw a line perpendicular to the principal axis, and you will be getting the image between f1 and o. Okay, so this is the same things are discussed or written here also: the position of the object, position of the image, and the relative size of the image. And the size of, always remember, for concave lens, size is always going to be very much smaller than the object, and the nature is always virtual and erect. Okay, you will not be getting on the screen, and the object is and the image is always you will be getting, will not be getting on the screen, always it will be inside the lens, and it is a erect image, not like this. Okay, this will be always erect image, perpendicular, parallel to the positive y-axis, you can say. Okay, so next we'll be discussing a problem from the NCERT. Okay, so you need to read the problem example question very carefully, so that you can gather all the information which is already provided in the problem. Okay, so here what all are the things given in the problem, that will first write it down. Okay, so here a concave lens. Okay, we are going to solve a problem of the concave lens. Concave lens means always you should, all the ray diagrams should come to your mind. Concave lens, it will be producing only virtual and erect. Okay, and the size of the image is always going to be small, very small. Okay, and the focal length is given here, that is your 15 centimeter. And where this focus is found, the focus is found on this side, so this is your negative x-axis, so the focal length is taken as minus 15. Okay, and what else is given? The image Okay, so the question will further read, at what distance the object from the lens the screen be placed, object from the, at what distance should the object from the lens, okay, at what distance the object is going to be placed, means it is asking you the object distance, it is asking you, so that it forms an image at 10 centimeter from the lens. Okay, and where the image is going to be produced, that is going to be produced at 10 centimeter. And as we know, for a concave lens, always the image is produced on this negative x-axis, and that is also erect, right? So a negative x-axis means the image distance we have to take minus. So image distance b, as you can see here, it is taken as minus 10 centimeter. Okay, and the focal length is also same, that will be produced on the negative x-axis. So this is also minus 15 centimeter. Okay, so the v is given, f is given, and you need to find the u. So put the length formula. What is your length formula? Length formula is 1 by b minus 1 by u is equals to 1 by f. Okay, so you need to find 1 by u, so keep 1 by u on one side, okay, minus keep 1 by u on one side, and rest all you take it to the right hand side. So minus 1 by u is equals to 1 by f minus 1 by b. So if you want to make this negative plus, then you have to also change the direct signs of this all. So 1 by f will be minus, 1 by b will be plus. So 1 by u is equals to 1 by b minus 1 by f. Okay, so this formula is derived now for this particular problem. Now place all the values instead of the letters. So v is equals to minus 10, so that is placed here minus 10, and f is equals to minus 15, that is also placed here minus 15. And if you will be solving this, you will be getting 1 by u equals to 1 minus 1 by 30. So u will be giving you the value of minus 30 centimeter. Minus 30 centimeter means the object will be placed 30 centimeter behind this optical center, means behind means on this side. Okay, because it is, you are getting the value in negative with a negative sign. So thus the object distance is your 30 centimeter. Okay, next what the problem is asking you, it is asking you to find the magnification also. As we know, the magnification is always h dash by h, size of the image by size of the object. And also it has another formula, that is v by u. For lenses it is plus positive v by u, but for the mirrors it is minus v by u. So as it is a concave lens, we'll be taking this v by u, because we have found out the u and also the v is already given. So this formula will be better to find the magnification here. So m is equals to v by u. Okay, the m is equals to b by u. So place the value of b and u, and you will be getting m is equals to 1 by 3, that is your positive 0.33. And this positive sign shows that the image is, okay, and magnification is positive. So this positive sign indicates that the image is your erect and virtual. And also from the ray diagrams, if you remember, the object, the mirror, the image is always going to be virtual and erect. Okay, and what is the size? Size is 1/3. Okay, because as we know, m is equals to h dash by h. Okay, so if you are getting m is equals to 1 by 3, it corresponds that the 3 times the size of the image is your size of the object. H is 3, when the h is 3 times, h dash will be 1 time. Okay, h is your object size and h dash is your image size. Okay.